Okay, so today we're going to be talking about parallel and perpendicular equations. So, first of all, let's draw some examples of what parallel and perpendicular lines look like. So, parallel lines are lines that look the same, but they're not the same line. They'll look something like that, and these will go on forever without ever touching. Okay? And these are parallel lines. So, that is what parallel lines look like. And then perpendicular lines are lines that intersect at exactly 90 degrees. So when they intersect, that intersection produces 90-degree angles. Okay, so it's kind of like the opposite kind of line. So this is a horizontal line. A vertical line would be the opposite type of line. Okay. Now, if you think about the equations for these lines, any line would have that equation y equals mx plus b, right? So m, that number in front of the x is your slope, and then the number adding or subtracting to it is your y-intercept. Now, if you think about parallel lines, since these are parallel and never actually touching, they're increasing at the same rate. Or if they were going down, they'd be decreasing at the same rate. Okay? So if you look at your equation, which part of your equation tells you the rate that it is increasing or decreasing? It's your slope, okay? So if you were increasing at the same rate, then they must have the same slope. So an example of two parallel line equations would be like y is equal to 2x plus 2, and then y is equal to 2x minus 3. Okay, so the slopes are the same. The only thing that's going to be different is the y-intercepts because they're obviously at different points on the graph. So when they intersect the y-axis, they're going to intersect it at two different points. So for example, these are going to intersect 5 spots away. Okay, they're still parallel though because the slopes are exactly the same. Something similar happens with perpendicular lines. Y-intercept isn't that big of a deal though. But with perpendicular slopes, let's say I have y equals 1 over 2x, and then we'll just give it a y-intercept plus 2. With perpendicular slopes, they're going to do the same thing every time. They're going to flip the fraction and then change the sign. So the number on the bottom is going to go on the top goes on the bottom, and then it changes signs. So for example, the perpendicular slope to this equation would become 2 over 1, but they would change signs, so it would become negative x, and then the y-intercept doesn't really matter at this point, so it could stay the same or change. I'm going to change it just because I can, so plus 5. Okay? But the big thing here is, and the point of this video basically is to talk about the slopes. So the slope of a parallel line is the same. The slope of a perpendicular line is going to flip and change signs. Okay, so if we come up here and we were to write a parallel slope to 9 over 10, it would be the same slope, 9 over 10. If we wanted to make that slope perpendicular, we'd have to flip it and change the sign. So it would become 10 over 9, but then change signs and become negative. Okay, same thing for 3 over 8. 3 over 8, if we want to make a parallel line, it would be still 3 over 8. Perpendicular is going to flip and change signs, so it's going to be negative 8 over 3. Okay, what about a whole number? So a whole number, again, slope of parallel slope to 3 would be 3. If we think of a whole number as a fraction, it's always going to be over 1, right? So if we need to flip that and change the sign, 1 would go on the top and it would be negative 1 over 3. Okay, not too tough. Now, let's talk about what happens if we just want to write a equation that is parallel or perpendicular. So, let's say I am given y is equal to 1 over 2x plus 4. And I want to write a line that is parallel to that. Okay, so parallel. Okay, so again, the slope would be the same. In order for it to be parallel, we just have to change the y-intercept. So 1 over 2x would be the same, and then it's not going to be plus 4 because that's going to be the same line. So we would have to change the y-intercept to something else. So let's do minus 7. Okay, that's parallel. Doesn't really matter what you put here as long as it is not plus 4. Then it's parallel as long as the slope is the same. Okay, let's do an example of a perpendicular. Well, no, let's do another example. Let's do one of our horizontal lines. So y equals 4. Okay, so if you think about that, that's a horizontal line right there, like 4 on the graph there. Or that's -4. So let's make this -4. Okay. So that's just right there at -4 on the graph there. So if I want a parallel line to a horizontal line, it just needs to be another horizontal line, right? It just can't be -4. So it'd be y equals 2. So that's like up here. That's parallel to it, right? There. Parallel line. Okay? Same thing with the x equals. X equals a number. You're going to just have a different number there for x. Okay? All right. Let's do an example of a perpendicular. Okay, so let's say I'm given y is equal to 3 over 4x minus 3. Okay, and I want to write a perpendicular equation to that. So again, y-intercept isn't as important on perpendicular. It's pretty much the only thing you have to change on parallel, but on perpendicular, we're more concerned about the slope, because the slopes have to flip and change sign. So I'm going to start off by just doing that. Y equals, if I flip it and change the sign, it's going to become -4 over 3x. And I could use the same y-intercept for here. It doesn't really matter, but I'll change it. So we'll do +2. Okay? And that's a perpendicular line. Now, some things that students struggle with is if we have that y equals 3 or whatever, that horizontal line. So again, if we're visualizing, I'll do it right this time. So there's my axis. It's a very not so good one. But y equals 3 would be this horizontal line right here, right? If I want a perpendicular line, I want one that's going to intersect that at exactly 90 degrees. So what type of line do I want? This is horizontal, so I want one that's going to be going at a 90-degree angle, so that would be a vertical line, right? So what's the equation for a vertical line? Well, just be anything that is x equals some number, right? So if I did x equals 3 or 5 or 7, just anything that is x equals would be perpendicular to it. So we'll just do 3 again. And that would be perpendicular, okay? And same thing, if it was x equals, y would be the perpendicular one. You just have to change the variable in front with those special case lines.